Here's a point though.
Okay, so we forgot to start the recording at the beginning. So just to give a quick synopsis to those of you who are watching the recording, like Jackie perhaps. Whenever we have a difference of squares, we're looking at the binomial to see if both terms are square numbers and if we can take the square root of it. So the square root of x squared is x. The square root of 4 is 2. And then the factors just become the square root of the first term minus the square root of the second term, and then the square root of the first term plus the square root of the second term. So as we go over these last three, if you're watching this at home, do the u-tries with me and then do the other ones. Try them on your own without looking at the answers. Okay, x squared minus 25. Mackenzie, can you tell me what this would factor into?
X minus 5 and x plus 5.
Good. X minus 5 and x plus 5. Square root of x squared is x, and the square root of 25 is 5. So those are the factors that we use. Evelyn, next one.
X minus 4, x plus 4.
Okay, good. X is the square root of x squared. 4 is the square root of 16. And the last one, Madison.
X minus 7, x plus 7.
Good. Okay, what about this last one? If we have a sum of squares, so both of these numbers are square numbers, could we factor it the same way?
No.
Why
Yeah.
not?
Shouldn't say anything. Disagree.
Okay, so you
Well,
say,
you can.
no, you say you can. Okay, so you say we could do like x plus 4, x minus 4? Okay, let's try that. X plus 4, x minus 4. Now, if I multiply through and I distribute, will I come up with x squared plus 16? What will I get?
X minus
X squared minus
Yes, yes,
16.
yes.
Yeah, so no, this does not work. We can't factor a sum of squares. It only works for a difference of squares. Any questions about this? Okay, moving on, let's talk about some examples where the leading coefficient is not 1. We're still going to do them the same way. We just have to take the square root of the coefficient in addition to the
So
variable.
it'd be 2x minus 5 and 2x plus 5?
Good. Square root of 4x squared is 2x. The square root of 25 is 5. So our answer would be 2x minus 5, 2x plus 5. This one, some people find this one to be a little trickier. Anybody want to volunteer to try the next one?
Is it 3T4?
It is 3t to the 4th. Remember, when you're taking the square root of variables to a power, you're not taking the square root of 8. So the 8 doesn't have to be a square number. It just has to be an even number because you're just taking half of it. Because when we multiply exponents, we're adding. And when we multiply powers, we're adding the exponents. So the square root of 9t to the 8th is 3t to the 4th. So we have 3t to the 4th minus what? What's the square root of t squared? T. So 3t to the 4th minus t, and 3t to the 4th plus t. What about the last one?
X minus 4, x plus y.
Good. X minus y and x plus y. Okay, 3 for you to try, so I'm going to pause the recording. Don't let me forget to turn it back on again. Okay, Jada, tell me this one.
4s minus 9 and 4s plus 9.
Miss Ladd,
Yes.
square root,
What?
or 14 times 14 is 196.
Okay, tell
Well,
me this one.
269.
Okay, Nick, do the next one for me.
Alright, 7a minus 10, 7a plus
Try saying square root on the keyboard.
No, Mackenzie do this one.
7a minus 10.
No, we're on this one.
Pay attention.
2r squared minus 5 and 2r squared plus 5.
Okay, now moving on, we're going to talk about recognizing and factoring perfect square trinomials. So I put a couple more examples like the ones you did on the warm-up. So if I take the whole quantity x plus 6 and I square it, I end up with x squared plus 12x plus 36. This one gives me this gives me this. So I want you to look at the three answers for a minute and tell me if you can sort of figure out a shortcut, how might you factor one of these trinomials to get the factor? So think about that for a minute, share your ideas.
Square root of
Square root what?
the x squared
Okay, so we can take the square root of the x squared,
and the second number.
this one? What is the square root of 12?
There is none.
There isn't a rational square root of 12, so.
There is 36.
So it's not, there is 36. So we could take the square root of this one, and we could take the square root of this one. Okay, and then Mackenzie's saying we could divide this by 2. Let's see if that works in every case.
Remember, just 'cause it's
Okay,
equal
so our
doesn't-
idea is that we take the square root of this and the square root of this, and we divide this by 2. So square root of this would be, square root of 4x squared would be 2x, that's good. Square root of 25 would be 5. And what did you say we should do this one? Just take half of it. It does not work on this one. Let's see if it works on this one, though.
No.
Square root of x squared is x, square root of 16 is 4, and half of negative 8 is negative 4. So that does work, but there's something else we have to consider. What is different about that middle one than about the other two? Well, the first one was plus 2. It's not 1. We don't have a 1 right here, we have a 2. So what you're saying essentially works, Mackenzie, but what happens is we're taking the square of the first term. So this one is the square of the first term. Not the square root, but the square. This one is the square of the second term in the original binomial. And the middle one is not just 2 times the second term. You have to take the product of both terms and then multiply by 2. So we're taking 6 times x times 2 is 12. So it's the product of the terms times 2. And that works for the middle one too, because 2x times 5 is 10x, 10x times 2 is 20x. If you were to look at this in your textbook, this definition with all the letters gives you the definition, I call it in math language, when they make it seem really complicated. It says a squared plus 2ab plus b squared is going to factor into a plus b times a plus b, which is the same as a plus b squared. Or if you have a negative sign, it's going to be negative. That's just telling you what we just observed. The first number has to be a square, the second number has to be a square, and the middle number has to be 2 times the product of the other terms.
Say square of first.
None of these are perfect
Which one?
Square of the first term,
Okay.
and this one says square of the second term.
None of these are perfect squares except for the
Okay, we're gonna actually skip, your notes are out of order. So I want you to go to the next page. We'll come back to the one where it asks you to choose. The examples that I'm giving you here are all perfect square trinomials. So we're gonna practice working with them, and then we'll look at the examples where we pick which ones are perfect squares. Okay, so Jada, square root of x squared. Square root of 25. 5. So my factor for this would just be x plus 5, the quantity squared. Okay, for the next one, Mariah, what's the square root of x squared? What's the square root of 36? 6, good. Now, when I take the square root of any number, it could be positive or it could be negative. The square root of 36 could be a negative 6 because negative 6 times negative 6 would be positive 36. So if the middle term is negative, you need to use the negative square root. So I have x minus 6 squared.
And next one is 3x minus 2
Good. 3x minus 2 squared.
What's the
Okay, 3 examples for you to try, and then we'll come back and go over these. So hit pause if you're watching this at home. Okay, let's go over these briefly. Evelyn, what did you get for the
X
first
minus
one?
8 squared.
Good, x minus 8 squared. So if the middle term is negative, you have to remember to make it negative in your answer. Good. Nick, next one.
X
Mhm.
plus 7.
Good. And last one, Maddie. 2x plus 4 squared. Okay, last slide asks you to tell which of the following trinomials are perfect square trinomials. So we need to look at the first term and the last term, and then see if we can combine the square roots to get the middle term. So square root of x squared is x. Square root of 16, we're going to use -4. Then I do -4 times x is -4x. -4x times 2 is -8x. So this one's good. This one is a perfect square trinomial. So draw an arrow just to show that it should go over there. I'm actually going to just move mine. Okay, next one. Jada, what's the square root of x squared?
X.
And the square root of 9? -3. Is this a perfect square trinomial? No?
No.
Okay, what could I put in the middle to make it a perfect square trinomial? What would it have to be? 6 or -6, either way would make it a perfect square trinomial. One would be an x minus 3, the other would be an x plus 3. Okay, what about the next one? Mackenzie, is that a perfect square trinomial? Why?
Yes, it is. What?
Yeah, so it is. Yes, good. Okay, next one, Nick, is that a perfect square trinomial? This one. Okay, let's check. Square root of 9x squared is
3x
3x. Square root of 4 is
2.
2. What's 2 times 3x?
6x
6x. And what's 6x times 2?
12x
12x. Is this a 12x? No, so it's not a perfect square trinomial. It has the two perfect squares on the end, but the middle disqualifies it from being a perfect square. Evelyn, next one. You want to look at the first and last terms to see if they're a perfect square. So first of all, is this a perfect square? Can you take the square root of that?
Yeah.
Okay, what is the square root of 2x squared? Wait a second. The square root of x squared is x. What's the square root of 2x squared?
1x.
There isn't one.
There isn't one, because you can't take the square root of 2. So this one is not a perfect square trinomial because of that first term. It's not a perfect square. Okay, Evelyn, try this one. Is the first term a
Yes.
perfect square? And what is its square root?
2x.
2x. Okay, what about the last term? Is this one?
Yes.
Okay, and what's its square root? -3. Okay, when we multiply these two terms together, 2x times -3, what do we get?
Not the whole. squared?
-6x, and then we double it, and we get -12. So this one is a perfect square. Trinomial. Okay, last one, Mariah.
No, it's not.
What's the square root of 4x squared? And the square root of 25?
No, it's 4x minus
What?
5 minus
Yeah, let's use -5 though, because of our negative middle term. -5 times 2x is -10x, and then double that. And you get -20x. This is not -20, this is -40, so this one is not a perfect square trinomial.
They're an automatic multiplication.
Do we get a worksheet today?
Yes, I'm going to give you a worksheet. We're going to go over 2 examples from the worksheet just to get you started. It's actually a classwork worksheet. You'll finish it before you leave, and we'll go over it. You won't have supper homework today.
Yes. Because I have a lot of sleeping pills now, you know. I just had a test.
Take us a whole week to do that.
I know, I forgot about it.
Okay, so we're doing the factoring special cases worksheet. We're going to do examples 1 and 3 together. So number 1, we have 16n squared minus 9. This one is a difference of squares, so these are the first kind that we did today. Volunteer to tell me what the factors would be for this one.
4.
Mackenzie?
4n.
4n,
Minus 3 and 4n plus 3.
good. 4n minus 3 and 4n plus 3. Number 3 is an example of a perfect square trinomial.
2n minus 5 and 3n plus
What's the square root of 16?
4.
It's 4, not 2, so.
So number 2.
Oh, we're doing number 3. Okay, so what would number 3 be?
4
B.
B
B?
plus 5.
Not plus 5,
Minus 5.
minus 5. And then what do I do to that?
Square it.
Square it, good.
So now we have to do that.
You have to finish the page, we'll go over it at the end.